So let's review for Chapter 8's test. All right, so number 11 gives these ordered pairs and then says determine whether this relation is a function. So remember, when you're looking at ordered pairs or at a table, what you want to look at is the x values. So that's the first numbers in each ordered pair. And if they're all unique, if they're all different, then it is a function. If any of them repeat, then it's not a function. So right here we see a repeat. 4 is used twice. So no, this is not a function because you can just say because there are repeats or because 4 repeats, either way. You could also say no because not all the x's are unique. That would be okay too. Okay, 12, use the table that shows the cost of gas in different years. Is this relation a function? So again, we just look at the x values, which in this case is the top row, and see if they're all different. And they are. That's 02, 04, 06. So since they're all different, we would say yes, it is a function. So yes, because all x's are unique. Okay, 13. Describe the sequence 6, 12, 18, 24 using words and symbols. Okay? So there's 3 things we need to do when they ask us to describe a sequence in words. First, we need to identify the common difference. So as you look, 6 to 12, they're adding 6. 12 plus 6 is 18. 18 plus 6 is 24. So the first thing I'd say is the common difference common difference is 6. Okay, now I need to also describe how the terms relate to their term number. Okay, so I'm just showing this to show this is the first term, the second term, the third term, the fourth term. So we can think about adding first. 1 plus 5 is 6, but 2 plus 5 is not 12. So they're not adding each time. Instead, we see 1 times 6 is 6, 2 times 6 is 12, 3 times 6 is 18, and so on. So the terms are 6 times the term number. So that's part 1 and part 2, the common difference and how the term relates to the term number. But we also need to talk about the equation that it would be. So it's always t equals. And essentially the sentence we just wrote tells us what it should be. We do 6 times the term number, so it's 6 times n. And you can, if you need to, you can check see if this works. If you plug in 1, you get 6. Plug in 2, you get 12. Plug in 3, you get 18. So that all works out. All right, 14. Write an equation and find the indicated term. So in 14, it asks us to do 6, 10, 14, 18, and wants the 47th term. Okay. So let's figure out the common difference. 6 to 10, that's plus 4, plus 4, plus 4. So I know it'll be 4n, but if I plug in 1, because that's the first term, 1 times 4 is 4, so that doesn't quite make it to 6. So I'll have to add 2 to make it get up to 6. So let's just double check this with the others. So 1 times 4 is 4, plus 2 is 6. 2 times 4 is 8, plus 2 is 10. 3 times 4 is 12, plus 2 is 14. So we have the right equation, and they want us to find the 47th term. So to do that, we plug in 47 for n. And when you do 4 times 47, you get 188. Then plus 2 is 190. So there's the equation, and there's the 47th term. Okay, 15, same overall instructions. This time it's 7, 14, 21, 28, and they want the 50th term. Okay, so the common difference this time is 7, where it's plus 7, plus 7, plus 7. First, second, third, fourth terms. So I know I have t equals 7n, because the common difference is always the number that's being multiplied by n. And let's plug it in. 1 times 7 is 7. 2 times 7 is 14. 3 times 7 is 21. So this works out well. Now the 50th term, we plug in 50 for n, and 7 times 50 is 350. Okay, next they show us a picture. So we have a square, and we have this. We have this. This is figure 1, 2, and 3. Now the question is, which figure in this pattern below will have 99 squares? So this is similar to what we did up here, but we'll actually be working backwards. Instead of plugging something in for n, we'll be plugging something in for t and solving for n. So first we got to figure out the pattern. Well, this one has 1 square. This one has 3 squares. This one has 5 squares. So 1, 3, and 5. So the common difference is 2. But when I plug in 1, I get 2. So I have to subtract 1 to get down to 1. Plug in 2. 2 times 2 is 4. Minus 1 is 3. 3 times 2 is 6. Minus 1 is 5. So that equation does work out. But this time, we know our value is going to be 99. They're asking what term number will that be. So we're actually plugging 99 for t and solving for n. We add 1 to both sides. We get 100 equals 2n. Then we divide both sides by 2, and we get 50. So the 50th term, or 50th figure in this pattern would have 99 squares. Okay, jump into the next page. Number 24. It says, find the rate of change for the linear function shown below. Okay, the first row is time. The second row is money earned in dollars. So I'll just put T for time, money for dollars. And we get 0, 31, and 62. Okay, so remember, rate of change means slope. So we'll need to use, see how the x's and the y's are changing. So the y's are going up by 31 each time. So I'll put 31 on top. The x's are going up by 4 every time. So I put 4 on the bottom. Now I would accept this answer, 31 over 4. You can also divide it in your calculator, and you'll see that it is 775. And what that means is this person is earning $7.75 per hour. Okay, 25. Got a table, 2, 4, 6. That's the number of people. We also have total cost if it's of adults or if it's kids. Okay, 36, 72, 108, 25, 50, 75. Okay, now that I've got that filled in, it says the table shows the total cost of tickets. Compare the rates of change. So we'll do that with the adults, and then we'll do it with the kids, see which one's bigger or smaller. So the adults, you notice we're going up by 36 each time. And the x's are going up by 2. So for the adults, it's 36 over 2, which is 18. So it's $18 per person if you're an adult. The kids are going up by 25 each time. So we put 25 over 2, and we get $12.50 per person. So adults, the rate of change is higher because it costs more per adult, $18. The kids has a lower rate of change because it only costs $12.50 per kid. Okay, 26 has a graph. It says the temperature one day is shown in the graph. Find the constant rate of change and interpret its meaning. So I will just give a rough sketch, and you've got your book, you can tell. You can tell on the graph, it goes, for example, hits the point 164, and it also hits the point, say, 572. And if you pick different points than me, that's fine. That's just the two I picked, so I don't have to recreate the whole graph here. Okay, so we want to find its rate of change. That's its slope. So we do y2, 72, minus y1, 64, over x2 minus x1. 72 minus 64 is 8. 5 minus 1 is 4. 8 over 4, is 2. So that means the temperature is increasing by 2 degrees per hour. I know it's increasing because the graph is going uphill, also because the slope is positive. That means it's increasing. It's Fahrenheit, 2 degrees Fahrenheit per hour. So the rate of change of that graph is 2. That means the temperature is rising 2 degrees Fahrenheit per hour. Okay, 27. We're finding the slope that passes through this pair of points. So we have the point 0, 1, and 6, 4. So I'll do y2 minus y1 over x2 minus x1. That gives us 3 over 6, which reduces to 1/2. 28, the two ordered pairs are -8, -2, and 4, 9. I do y2 minus y1 over x2 minus x1. Don't forget, anytime you see minus and negative, you change it to plus or positive. So 9 plus 2 is 11, 4 plus 8 is 12. -29, -3, 7, and 5, -1. So we do y2 minus y1 over x2 minus x1. Change this to plus or positive. -1 minus 7 is -8. 5 plus 3 is +8. -8 divided by +8 is -1. Or if you said -1 over 1, that's also fine. Okay, number 30, the points are 6, -4, and -1, 10. So y2 minus y1 over x2 minus x1. We change minus and negative to plus positive, so that's 14 on top. -1 minus 6 is -7, and 14 divided by -7 is -2. Okay, 31, we're also figuring out a rate of change. It says a lizard is crawling up a hill that rises 5 feet for every horizontal, that'd be x, change of 30 feet. So every 30 feet of change horizontally, it goes 5 up. So I did rise over run. It's rising 5 feet as you run 30 feet horizontally. So the slope, we could reduce this and it would be 1 over 6. Okay, last thing is to do the back side of the worksheet. So the number of centimeters, y, in a linear measurement varies directly with the number of inches in a measurement. Vallejo's height is 160.02 centimeters, or 63 inches. So I'm going to pause right there. I've got y equals kx. That's my direct variation equation. And they gave me the variables y and x. Y goes with centimeters, so I put 160.02 in for y. And I put 63 in for x because that's the inches. Then I divide both sides by 63. And I get k is equal to, give me a moment, 160.02 divided by 63, 2.54. So our equation then is y equals 2.54x. And it asks, what is Agape's height in centimeters if she is 68 inches tall? So inches goes with x. So I plug in 68 for x, multiply by 2.54, and I get 172.72 centimeters. Okay, a bottle of 120 vitamins costs $6.60. If the cost C varies directly with the number of vitamins V in the bottle, what should a bottle of 300 vitamins cost? So I used the variables they gave me and do them in order. This one goes where the y is because it came first. This goes where the x is because it came second. So 120 vitamins cost $6.60. So I divide both sides by 120. Oops, hold on. Okay. So we get 0.055 for K. So this one up here, the K meant that's how many centimeters are in 1 inch. This is telling us this is the cost of a single vitamin. So a single vitamin costs 5.5 cents. So our equation would be C equals 0.055 V. And if we want to figure out how much 300 vitamins would cost, we plug in 300 for V, multiply by 0.055, and we get that the cost would be $16.50. Okay, number 8, Sophie received $32.25 in interest on an $850 deposit in her bank account. If the interest, I, varies directly with the amount deposited, D, how much would Sophie receive for the same amount if she had $1,400 in her account? Okay, so $850 is the deposit, so we put that in for D. $32.25 is the interest, so we divide both sides by $850. Okay, so we get about 0.038, which means she's getting a 3.8% interest rate. So our equation would be I equals 0.038 D. And the question is, how much interest would she earn if she deposited $1,400 instead of $850? So we plug in $850 for the deposit, multiply by 0.038, and we get that she would have earned $32.30 in that case. Oh, sorry. I did that wrong. Let me try that again. We already did the 850. That's why that number was so close to this one. It's a little bit different just because we were rounding the interest rate. But 1400 is what I should have plugged in. I wondered why they're so similar. So 0.038 times 1400, we get $53.20. That makes more sense. Okay, Karen earns $89.60 for working 8 hours. If the amount, M, that she earns varies with H, the number of hours she works, how much will she earn for working 30 hours? So $89.60 is what she makes. She works 8 hours. So we can find K by dividing both sides by 8. Get $11.20. So that means she makes $11.20 an hour. And then to figure out how much she earns working 30 hours, plug in 30 for H, multiply by 11.20, and we get $336. So that's how much she would make if she worked 30 hours. Okay, last one. The number of gallons of G, number of gallons G of fuel used on a trip varies directly with the number of miles M traveled. If a trip of 214.5 miles requires 11 gallons of fuel, how many gallons are required for a trip of 400 miles? Okay. So we divide both sides by 214.5. 11 over 214.5. We get, I'll just say 0.051. So our equation is G equals 0.051 M. And we want to figure out how many gallons we needed for a trip of 400 miles. So I plug in 400 for M, multiply by 0.051, and we get that 20.4 gallons will be needed. Okay, so review these kinds of problems because these are the kind of problems that you will see on your test. Good luck.